Okay, so the question says, in each of these squares, the marked length is 1 unit. Which of the squares would have the greatest perimeter? So we have one square, like we have different squares, and they give us one measurement of the square, and that measurement is always 1 unit. And they're asking us which would have the greatest perimeter. So we always have to remember that the perimeter is equal to 4 times the length of the square. This is always for squares, okay? Because each side is equal to the other side, and the perimeter is the addition of all the sides. So let's do this one by one. So in the first square, they give us this square, and they tell us the side is 1. So here they show that this is the dot, like the point, the center of the square. So we know that half of the diagonal is equal to 1. So half of the diagonal is equal to 1. We can add that the other half of the diagonal is equal to 1, right? So we now have the length of the diagonal, which is 1 plus 1, 2. So that's the length of our diagonal. And now that we have the length of the diagonal, it's very easy to find the length of the sides of the square. So you remember that a squared plus b squared is equal to c squared. So we are going to call this a, b, and c. In this case, the Pythagorean theorem is true because this is a right angle. Therefore, these two sides are equal to the hypotenuse squared. So we can rearrange we know the value of c squared, so we can rearrange our equation. So a squared plus b squared is equal to 2 squared, right? That's the value of c. So we can continue going because we know the value of 2 squared. So a squared plus b squared is equal to 4. 2 times 2 equals 4. Okay? We also know that a square, the lengths of a square, the sides of a square are all equal, because that's basically the definition of a square. So we can additionally include that we know that this side is equal to this side. So we know that a squared is equal to b squared. Okay? Now we can change the Pythagorean theorem to our favor in this case, because we know that a squared is equal to b squared. So we're going to have a squared plus, and we're going to replace b squared for a squared because they equal the same. So they're going to give us the same answer. So a squared plus a squared is equal to 4. So in this way we have the same variable, and it's easy to solve for that variable. So a squared plus a squared is equal to 2a squared, and that is equal to 4. So now from there we just solve for a squared. So we divide by 2, and whatever you do on this side, you do on this side. So a squared is equal to 4 over 2, which is equal to 2. And a is equal to the square root of 2. But we are not done there yet. So we know that a is equal to the square root of 2, right? And we said that the perimeter is 4 times the length. So the length of one side of the square is the square root of 2. So to get the perimeter, we have to do 4 times the square root of 2, and we can just leave it like that because we don't have to simplify it anymore. That's not part of the answer. They're just asking for the longest one. Okay, so they give us 4 root of 2. So now let's continue to the next square. So here they give us a square. I'm going to draw it like straight, and they tell us that half of one side is equal to 1. So this is actually very easy. So half of one side is equal to 1. We can say that the other half is equal to 1 too, because they're equal. So therefore, we know that one side is equal to 2, because 1 plus 1 is equal to 2. So this is equal to 2, this is equal to 2, and so on. So in this case, the perimeter would be 4 times the length, and we know that the length of a side is 2, so 4 times 2, and it is equal to 8. 8 is greater than 4 root 2, so we know that square p is not the answer, so a is not the answer, so we cancel that out. Okay, the next square is a very interesting square. I'm going to do it like this. And here is the center, and they tell us that from here to here, the length is 1. So here I just do it based on logic, okay? Because we can solve it, actually, but you also need to do it to logic to save time. So we know that this one is not the right answer, but maybe this one is actually less than this one, which with logic it actually makes sense, because here it is actually telling us that the diagonal is less than 1. Because if you like lengthen the diagonal, it's 1, but if you close it up, the diagonal is less than 1. And here the diagonal was 2. So if the diagonal is less than the diagonal here, we are going to know that the sides here are less than the sides here. And the perimeter here is going to be therefore less than the sides here because it's proportional. So we know that r is not the answer because it's less than the perimeter is less than the perimeter of square p, and square p is not the answer. So we still have b as an ongoing winner. And the last one is actually very easy. So we have our square, we have the center, and they tell us that from here to here, so they tell us the length of one side, 1. So from there we can just do the perimeter is equal to 4 times the length, and the length is 1, 4 times 1, so it is equal to 4. 4 is greater than 8. 4 is not greater than 8, so the answer is 8. And the correct answer would be B. Okay? Okay. So question 20 says, the increasing sequence of positive integers 1, 2, 4 has the property that each term from the third onwards is the next positive integer which is not equal to the sum of any two previous terms of the sequence. How many terms of the sequence are less than 2016? Okay, so let's lay out the information we have. So we know that the sequence starts 1, 2, 4, so on. Okay, so we know that each of the next term is going to be the next positive integer, and it is not going to be equal to the sum of any two previous numbers. Okay, so let's see how the sequence starts. So we have 1, 2, 4. Then can we have 5? No. 4 plus 1, 5, 6. 4 plus 2 equals 6. So 7, we can have 7. Remember that it's between two numbers. So you could do 4 plus 2 plus 1, but that's not two numbers. Then comes 8. No. 7 plus 1, 9. 7 plus 2, 10. Then comes 11. 10 plus 1, 12. 10 plus 2, 13. And so on. So now you have to find a common pattern here. So let's see. if you ignore the 2 for a second, there's an easy common pattern. We're going to ignore the 2 for a second. And we are going to notice that the terms of the sequence are those numbers that are 1 more than the multiples of 3. So for example, we have 4. Oh well, 1. 0 times 3 plus 1 equals 1. 1 times 3 plus 1 equals 4. 2 times 3 plus 1 equals 7. 3 times 3 plus 1 equals 10. 4 times 3 plus 1 equals 13. And we have our sequence, except from the 2. So this is actually very useful when we are going to figure out how many numbers are before the 2016 term. So we know that these are the multiples of 3 plus 1. So we know that they're going to be 2016 divided by 3, which that equals 672 terms, which are going to be less than 2016. And we have to be very careful to include 1 instead of 2017. So this is without including the 2. Okay, because if you see here, if you do 13 divided by 3 is about 4. So we have 1, 2, 3, 4 numbers less than 13. 10 minus 1 divided by 3, 3. 1, 2, 3. 7 minus 1 divided by 3 is how much is it? It's 2. 1, 2. Okay, so we know that we need to include the 2. We need to add 1. So we know that there are 673 numbers in total before 2016, including the 2. So the answer is E.